Hello, Assalamualaikum. My name is Cik Nur Ansyafiqah binti Cik Zaidul. My matric number is 2023608326.
Hola, my name is Tazmira Ayuni binti Azman and my matric number is 2023854408.
Hello, my name is Nur Hamiza binti Muhammad Azli and my matric number is 2023610832.
Hello, my name is Munzulaika binti Wan Juno and my matrix number is 2023460356.
Probability is analysis of the likelihood that an event will happen. The concept of probability is about chance and opportunity. It is the ability to understand and predict the outcomes. The value of probability lies between 0 and 1. If we assert that an event will occur, the probability is 1. But if there is no chance that an event will occur, the probability is 0. We generally use probability to understand the world around us to judge what likely to happen and what isn't likely to happen. Real life can be chaotic and lot of things happen that don't seem to make any sense. We cannot always know what is going to happen, but you can do your best with the help of mathematics to predict what is going to happen so you can make good decisions every day. Everything from a conflict to the weather can be predicted by probability.
So here are the objectives for this project. First is to record the frequency of each flavor. Second is to calculate the experimental probability and theoretical probability. Third one is to calculate the percentage of the difference between experimental probability and theoretical probability when picking up the sweet of each flavor. Fourth is to show continuous probability distribution function, and the last one is to show continuous probability distribution function.
The following project is related to the application of probability that frequently occurs in daily activity. For instance, if one were to flip a coin, the possible outcomes are head and tail, where each has some chance. Simply put, probability is the occurrence or the chance that something will happen. As part of this project, an experiment involving the picking of sweet was conducted. From it, we can conclude that in picking sweet, the possible outcomes are lemon, mint, or coffee. Additionally, the probability of an event is obtained by using the formula number of favorable outcomes divided by the total number of outcomes. In this experiment, there are 30 sweet and the selection is with replacement. Each pick is independent. Finally, the student performing the experiment must close the eye while picking a sweet.
Now, we are moving to methodology. For our assignment, we were assigned to carry out the third experiment, which involves using sweets. In this experiment, we will randomly select sweets with replacement for approximately 30 trials. This is the procedure to do this experiment. First of all, we need 3 different flavors of sweets, which is lemon, coffee, and mint. Then, put all the sweets together in one box. Next, we put a paper with a hole in the middle as the lid of the box. One Zulaika, who are going to pick up the sweet, wear an eye mask to make sure she does not see what flavor of sweets she going to pick up. After that, one Zulaika picked one of the sweets in the box randomly. Then, Hamiza recorded what type of flavor that Zulaika picked. For step 7, one Zulaika put the sweet back into the box and I mixed the sweets again. After that, we repeat procedure 5, 6 and 7 for 29 times more. Lastly, the outcomes of the experiment recorded on the table.
Based on the experiment that we did before, this is the result that we record the frequency of each flavor that we pick up. As you can see in the table, we use 10 pieces of lemon candy and we pick it up for 10 times. Next, we use 12 pieces of mint candy and we pick it up for 11 times. And last but not least, we use 8 pieces of coffee candy and we pick it up for 9 times. Next, we have to find the experimental probability for each flavor candy, which is we have to divide number of time event happen and total of trial. For lemon, we get 10 over 30. For mint, we get 11 over 30. And last one, for coffee, we get 9 over 30. The theoretical probability is the number of candy that we use for this experiment divided by the total of all flavor candy that we use, which is lemon we get 10 over 30, mint we get 12 over 30, and lastly coffee we get 8 over 30. So next we have to find the difference between experimental probability and the theoretical probability for lemon candy. We calculate the experimental and theoretical probability beforehand, so we minus them. After that, we multiply it with 100% because the answer want it in percent. This question we do it the same thing as before but for mint candy. Lastly, we do it again to find the difference for coffee candy. Last but not least, we have to find the experimental probability that the selected sweets is not lemon. We all know that if we add all the probability, we get 1. So if we want to find the selected sweets are not lemon, we have to minus 1 with the probability of mint and coffee, and we get the answer which is 2 over 3.
So here it comes for the solution for probability of a random variable. The length of time required to develop a resource website denoted by random variable W in hours has a probability density function given as follows. So as you can see, these are the information that given for this question. A probability density function must satisfy two conditions. First, it must be non-negative for all values of y, and second, the total probability or the area under the curve must equal to 1. Does this function satisfy this condition? Let's verify this step by step in the next slide. So for question A, we need to determine the value of y. To ensure the total probability is 1, we need to calculate the integral of fy over its range, which is the integral of 0 until 3 over y bracket 3y minus y squared bracket dw equal to 1. And then we need to expand the function. Next, integrate them term by term to get the final answer for y, which is 26 over 9. So for question B, we are focusing on finding the probability that it will take more than 30 minutes for the resource website to be developed. Mathematically, this is represented as P bracket W greater than 0.5. We need to know that P bracket W greater than 0.5 equal to the integral of 0.5 until 3 FW dW. Before we integrate the FW, we need to substitute the value of y that we get from the previous question, which is 26 over 9, into the function to get the FW, which is 1 over 3. After we integrate the FW, we need to substituting the limits, which is from 0.5 and 3 to get the final answer, which is 5 over 6. Okay, for the last question, question C, given that the continuous random variable b equal to w plus 2 over 4, determine the value of EB. First, we need to substitute the value of b into EB, and then we need to factorize that. By using the mean formula, we need to integrate the function of EW from 0 until 3 until we get the expected value for EW is 3 over 2. And then we need to substitute the value of EW into the previous function for EB to get the final answer for EB, which is 7 over 8.
To sum up, our group conducted an experiment titled Picking Up a Sweet to study probability. We placed 3 types of sweets, which is lemon, mint, and coffee, in a box. Pick one randomly 30 times with replacement and recorded the frequencies, which is we get 10 lemon, 11 mint, and 9 coffee. We calculated experimental probabilities, compared them to theoretical probabilities, and noted that variations in size, shape, or texture might have caused bias. To improve, we suggest using sweets of uniform size, shape, and texture. This experiment enhanced our understanding of probability and problem solving in such scenarios.